Hi folks, welcome. Thanks for joining us. My name's Pete. We're live here again in StewMac studio for episode 3 of our 57 mini Tweed amp build along live stream video. If you were here with us last time for episode 2, welcome back. If this is your first video, welcome. Joining us again today is Tommy Stumpp, our videographer Rachel, and our director Susan. All right, so we got a lot to cover today. Similar to last episode, we've got quite a few steps to go through. Last time we went through populating the chassis, getting it ready for the eyelet board. Today we're going to be turning a blank eyelet board and populating it so that it ends up looking like this. So I think before we get into all those steps, we're going to review some safety procedures first. So Tommy, you ready to take it away?
Yeah, Pete, thanks. So in our first episode, we went through step by step how to fully safely discharge a tube amplifier. A tube amplifier that's been plugged in with tubes in it is going to have the potential to have lethal voltage. So you really need to follow every safety precaution you can. That includes things like not wearing jewelry, like rings or necklaces, but it also really is important that if you're working in a circuit that's been live, that you discharge those caps before you go poking around, especially if you're troubleshooting. So again, episode 1 goes through all of that, including how to use a snuffer stick and a multimeter.
Right, and you can also find all of these safety tips on page 6 of the instructions. A couple other quick ones, wearing rubber-soled shoes, right?
Absolutely.
So you're not grounded.
Yep.
There's some other ones here. We've got
eye protection.
Yeah, eye protection.
Yep.
You can have solder pop, and you don't want that molten metal in your eye.
Right.
Stay suspicious, stay ever vigilant, make sure you're not about to touch something that's under load and get a nice shock.
Right. And again, for our purposes today, we're not going to have any voltage present because we're not plugging anything in yet, but it's just always good to keep all of those things in mind. Start with good habits because you're working on a live circuit.
We were just asked to get closer to this thing.
Sure. Turn it around upside down here.
All right.
So that's what we're going to have at the end of this episode.
That's your sassy cat.
You're welcome, Sassy Cat.
All right.
Is that a
And
good shot, Rachel?
Looking into me?
All right.
yeah.
Throw this away.
Yeah, and you can find that obviously in the instructions as well on page 21, which we'll end up at today.
Absolutely.
But before we get into the steps, what are we going to be doing today?
So essentially, we're going to populate this entire board with every component. This is the main part of your circuit. We'll talk about what the individual components do along the way. But what we're going to be doing is wrapping all of our components first. Then we're going to inspect our work. Very important. Anything out of place or in the wrong polarity in some instances can cause problems. So it's really important that you inspect your work as you go and then again at the end. And then finally, we're going to solder. We're going to save the soldering till the end just because you don't want to solder any of these more times than you need to. Generally, that's going to result in a cold joint if you are reheating an eyelet over and over and over. So again, all that information is in our excellent instructions as well. Recommendations on wrapping leads, which is essentially just making a good physical connection before you make this soldered final connection.
Yeah, you can find that on page 16 of the instructions, as well as soldering tips. Like Tommy said, we're going to get into the soldering at the end of the episode. So now let's get right into it. Step 31 on page 17.
Yeah, because we got a long way to go. So a 1.5K resistor and 2 jumpers. Now this step, this resistor isn't quite long enough to span from eyelet 11 to 26. So what we're going to do is tape that in place just temporarily while we build our circuit. Once we solder it, it'll be held in place. Is that a good shot, Rachel? Cool.
You know, Tommy, we mentioned inspecting our work as the second step. If any of you joined us for episode 1, we did find some little misstep there upon further inspection. Tommy, can you elaborate on that?
Yeah, so in that episode, I believe it was the first episode, I misnumbered this board, and some of our kind viewers pointed that out. So through Studio Magic, race gone ahead and fixed our board so that it matches the instructions. It's really not the end of the world. Are just there for you, the builder, to follow the instructions.
And can you tell us what you're doing with the tape there?
Yeah, I'm just holding this lead because as you can see, I'm holding the resistor. As you can see, the leads aren't quite long enough to hold themselves in place in that eyelet. So then I'm just gonna get a little soldering aid and push those down, bend them over so that they're ready to make a good connection when we actually solder them in a few minutes. So I've got my resistor in place. Now I'm going to get my 2 jumpers. We've got a 3-inch piece of green wire. You can see I've got my shop rule here. Really good to have this on hand for this entire episode. We're going to be cutting a lot of jumpers, and they really do need to be the proper length. So I've got my 3-inch green wire. I'm going to wrap it into eyelet 11. And wrapping these, you can bend them ahead of time with the bending pliers. And essentially, you want to make a good physical connection with the eyelet. Now I'm going to hold it with that bending pliers and then bend my wire so that now it's kind of pinching that eyelet. If you can see that. Cool. Same deal. We're going to do that again, a 3-inch yellow jumper.
And Tommy, what's the difference between the green wire and the yellow wire we're using to make these jumpers?
The green wire is a larger gauge. We generally use it for AC connections or for the ground connections. It's still solid core pushback wire, just like they used in the 50s. This yellow wire is easier to bend. You can bend it with your fingers generally. Pinch it on there nice and tight. If these start falling out, you can do what's called tack soldering, making a very small temporary solder connection. Again, you don't want to make a big joint if you have to add any more components. So again, if you want to follow the instructions, you're not going to have any trouble resoldering anything. But if you want to do some of those solder joints when a joint is fully completed, you can do that. So moving right along, step 32, we're going to install 2 68K resistors. And that is blue, gray, orange.
And I'll Rachel get Nicholas of that. I'm just going to adjust this slightly.
All right. And quick reminder, we are live here so we can take your questions while we're doing the build.
Did you get a good shot?
As well as we can always address any questions that you leave in the comments after an episode. So on episode 2, Chubam asked, what kind of solder are you using? Is it also recommended for using on guitars?
Yeah, so we're using 6040 tin of lead. It's our Kester solder pack available on StewMac.com. Really handy, so you're not messing around with a big loop or what have you. But again, it is lead solder, and I just don't really find that the lead-free stuff does a great job, but it is absolutely the same stuff you could use on a guitar.
All right.
So as you can see here, I wrapped these two together on the side of hole 13, and I pulled that through that eyelet, and now I pulled the other 2 leads through on eyelets 9 and 10. And you can see on the back of the board, I pulled them through like that, and I wrapped them so that I can get my other leads in there, and they'll just stay in place. You can see this lead jumped out on me. No big deal. There's not that many leads in this kit, so you don't need to worry too much about losing your place. You can generally see right where something like that came from, but I am just going to go ahead and tack solder that just for a little bit of peace of mind while we build the rest of this circuit today.
Great. Can you just walk us through the steps as you do this?
Yeah,
What
it's
exactly
just
are you
like
doing?
it's just soldering something so it stays in place, forming a temporary connection. So I'm just going to tin my tip here and pop a little solder on there. And that guy is not going anywhere now. Again, I didn't fully make that connection because we're going to do that at the end. But for the ones that are giving you any trouble jumping out of place while you're loading your board, you can tack solder just like that. And again, I just used a minuscule amount of solder to get it to stay in place for me, avoid frustration. So for the rest of this step, now that we've got our jumpers wrapped, I'm going to cut a 2-inch yellow jumper and a 4-inch yellow jumper.
All right. While you're cutting those, we've got a question here from Sassy Cat. They ask, what do the various resistors control as they're being placed on the board?
So they all serve kind of different purposes. Some are load resistors. This is a cathode load resistor. It essentially sets the bias for your power tube. These are grid resistors and also mixing resistors. They also serve as a voltage drop circuit for your low input. We'll get into the inputs and why there are two later, but rest assured, resistors all can serve multiple purposes, not just one purpose in this circuit. So I've got my 2-inch yellow jumper. Wrap it onto eyelet 9. And a 4-inch jumper onto eyelet 10. Here we go. And now we're going to add a 5-inch yellow jumper from the back of the board. So there we go.
And while you're running that, we do have a little follow-up question to the solder, earlier solder question. Ben M asks, do you recommend 80-20 or 60-40 for guitars?
I always use 60-40. It's just the right stuff. You can experiment with it if you want, but I prefer 60-40. And again, that's 40% lead to 60% tin. So I've got that jumper from 13 wrapped through and pulled through hole 25. 25 doesn't have a metal ring in it because there's no soldering that happens. It's just essentially a pass-through. So now we're going to install a cap and a jumper for eyelet 33. That's a 22 UF orange drop cap. The only orange drop caps in this circuit are 0.022, so you don't need to worry about mixing these up. Also, these don't have polarity, so you can install them in any orientation, I guess either orientation. But I'm going to install it like it is in the instructions. So I like to mock this up, get it centered on my board, and then figure out where those bends are going to be. So you can see I've got it bent through there. It's in a good location. And I can find my other spot. Now it drops right through the board. And we'll wrap it. I'm going to pull those leads down towards each other so it kind of hugs that circuit board. You can see that. Can you see that, Rachel?
Yeah.
Nice.
So Tommy, for those of us who are maybe more familiar with orange drop caps, installing them to create tone control in a guitar, these are significantly larger than the 22 microfarad orange drop caps that I'm used to using with like a humbucker.
Yeah.
What's the difference there?
So these are rated for 600 volts. And since it's in an amp like this, they don't really need to be small. You could probably pay more for the same value cap that was smaller, rated at 600 volts. But again, the big delineation is these are 600 volt caps. So I'm going to add my 4-inch jumper to eyelet 8. And again, I'm just bending that on the bottom of the board with my finger. You can use a bending pliers if you like. And that's going to jump out of there. What I'm going to do is go ahead and tack solder this guy too. After I get it installed here, because it might just keep jumping out on me.
I guess another question that I had was, for those of us like myself who are more used to working on a PC board, what can we expect to be different working on this eyelet board compared to a PCB?
Obviously, it's a lot more spacious. The name of the game with PCBs is getting as many things in as small of a space as you can. With this, there's not as much concern for that, although it will kind of look busy at the end. The other thing is most of this, you're not going to have to worry about shorts. The eyelets are spaced out nicely, so you don't really need to worry so much about trimming all those conductors really tight against the eyelets in a pedal kit. So now we are going to add 2 100K resistors and 1 jumper.
Yeah,
and that is, let's see, that is brown, black, yellow. Now these look a little different than the first 3 resistors we used. Same thing, just a different manufacturer. Brown, black, yellow. Is that a good shot, Rachel?
Me.
All righty. Again, resistors don't have polarity. Not important which way you install them, but I'm going to do the same thing that we did with our 68K resistors. Just kind of twist those together so they stay a little bit. Get them wired through. And then bend those leads down into eyelets 24 and 22.
Tommy, can you describe your process as far as placement on the board here?
I like to have things as centered as possible. Tidiness is a big thing. It can actually make your amp sound better if you work in a more tidy way in certain places of the circuit. And we'll talk about some of that later, but ideally everything just looks uniform, and you don't have things coming way up off the board. The less of these leads there are, the better, because every little bit of lead can act as kind of an antenna, if you want to think about it like that.
Okay, so if you center them, then you've got even leads when you trim it,
Right.
making them as short as possible.
Right. So now we're going to add a 3-inch yellow jumper to eyelet 24. There we go. You don't need to be as careful with the yellow wire as far as lengths. You can go a little longer on some of these. With the green wire, you want to stick to pretty much what the instructions say, because there's only just what you need in this kit as far as the green wire. And I'm going to go ahead and tack solder this lead as well, just because I know these yellow ones like to jump out when I'm flipping this back and forth to show the camera what's going on.
All right. And again, folks, we are live here, so please feel free to send us any of your questions in the chat. We'd be happy to address them. Really, that's why we're doing this live here, so you can follow along and get your questions answered right away.
Yeah. Can't let Sassy Cat have all the glory. All right. So now we're going to move on to step 35. Now, this is one step where I would actually recommend you cut this a little bit longer than the instructions. We're going to turn the board over and attach a 2 1/4 inch yellow jumper. I like to cut this one 2 1/2, just for a little bit of added security, and so I can wrap it a little bit further through the eyelet. 2¼ is just exactly right. 2½ is just a tad more, and it gives you a little more flexibility. So what I'm going to do is flip my board over and pull these guys with me. And we've got eyelet 14 here, and we're going to go over to eyelet 18 here. So I'm going to add this jumper through that hole, pull this guy back on here. I don't know if you can see all that, Rachel.
Yes, you can.
And go through this hole. And then when I flip my board back over, I should see both of those ends poking out, which is good. That's what I want to see. Got it. All right. So again, as I go, I'm inspecting my work, making sure it looks tidy, making sure all the colors match on the resistors, and making sure anything that's polarized is installed in the right direction. We haven't gotten to anything polarized yet, so don't worry about that.
All right. Yeah. So we're moving right along. On to page 18 now, step 36.
Yep. We're going to install our other .022 cap. These are coupling caps. As Pete said, you often see these used in a tone circuit. The other thing they can do is decouple DC voltage from AC voltage. So in a guitar amp, we are using DC voltage to power everything. We're using AC voltage as the signal. Your guitar puts out an AC signal. So we need to sometimes remove the DC voltage from the signals running together to make sure that we're just amplifying guitar sound and not power, your wall power. So that's what these two caps are doing, called coupling caps. So we've got that .022 added. We're going to add a yellow jumper, 2 inches. And that goes on eyelet 22.
And for anyone following along in the instructions, you may notice that there's really only one of these capacitors filled in or colored in on the instructions. For simplicity, following along step by step, you'll see that all of the components that we've already installed have been grayed out, so you can just focus on what we're installing on this page.
Yeah, and I'm going to tack solder this as well, just because when we're on camera here, flipping this board around, these like to jump out. If you're working at home, taking your time, you absolutely don't need to tack solder anything, since you can kind of just keep your board stationary. But since I need to flip it over for the camera, I like to just give myself a little peace of mind. So now we're on to step 37. We're going to add a 220K resistor. Now there's an issue in the instructions. The color is wrong on the drawing, but it's not a big deal. It's actually red, red, yellow, not red, red, orange for 220K. And that is the other one, the other one that matches these 100K resistors, same manufacturer, so it looks a little different from our classic looking carbon comp resistors.
Yeah, and to clarify, in the parts list on page 3, the colors are listed correctly and displayed correctly.
Right.
As well as you can always double check a resistor's value. We have the resistor color coding chart on page 7.
As well as with a multimeter.
That was my next one. Yeah, exactly.
Yeah. And if you're ever worried that you're maybe confused on the color codes, or if you think the instructions are confusing or something, always double check your work with a multimeter. That's, again, goes right in hand with inspecting your work as you go. So we've got our 220K resistor. We're going to add a jumper, a 5-inch jumper. And again, this is going to be on the back of the board. And that is going to go from eyelet 7 through hole 19. Get in there. There we go. And there we are. And if you pull that, give it a little tug, it'll hold itself in place. Shouldn't drop out of there at all. Okay, we're on to step 38. We're going to add a 22K resistor, and this is that red, orange. And we're going to add a jumper.
All right. While you're installing that, Tommy, can you explain to us exactly how you would, I guess, measure or test a resistor with a multimeter?
Sure, I can just show you with this one.
Okay. And I guess follow-up question to that is, how close should it be to within that spec, within the value that's listed?
So 10% is generally kind of a rule of thumb with these. Most amplifier schematics list all DC voltages with a tolerance of plus or minus 20%. That's due to drift and component values and manufacturing tolerances and wiring and wall voltage and transformer windings, and you name it, anything can change it. But what we can do is get as close as we can to the vintage circuit by checking our values and making sure we're as close to what they were intending to work with back in 1950, 50 and on. So what I'm going to do is get our multimeter out. I'm going to set my value on ohms for resistance to the closest value above what I'm checking. So we're going to go 60K, again, 60,000 ohms, because we're checking a 22K resistor. And I like to just pin it down, because if you hold it, you can change the value, believe it or not. So we're looking at 22.05. That's well within range. So we're good to go there. And again, doesn't matter which side is which on a resistor. It's going to read just about the same every time. And if you're ever worried about your tolerances, you can go through with the parts list and check those ahead of time. If you find something way out of whack, you can send us an email, service@StewMac.com, and we'll get you the right parts sent out just as quick as we can.
Yeah, and the nice thing about this kit is all of these resistors, you'll see they have a gold band at the end, which is the band that indicates this tolerance.
Right.
And gold means that it's 5% plus or minus tolerance.
Yeah. And that's pretty good. There are tighter tolerances in different resistors, but carbon composite resistors like this that are vintage appropriate are generally 5% at the most that we've found. So we've got our 22K resistor. We're going to add our 1.5 inch yellow jumper to eyelet 21. And as before, this guy might fall out, so I'm going to tack solder it as well.
And while you're doing that, I want to give a quick shout out to Bob Murphy, who already went ahead and finished his amp. Even doing that, he's still tuning in and hanging out with us. So congrats, Bob. I completely understand not being able to wait to finish it.
Totally.
Would have been the same way.
Yeah, it's hard for me to stop when we get to the end of our episode. Congratulations, Bob, on building a hand-wired point-to-point amplifier. So we're good on step 38. We're going to move on to step 39. Add a 1.5K resistor and 1 jumper. Sorry, Rachel.
Oh, you're fine.
And there's our 1.5K resistor. I'm not going to test every one of these. Just wanted to show you that quick process. And again, I rarely see these come defective out of the box. So you can be fairly confident that all the parts are going to be all right. So again, I'm just getting that as centered as I can between there. I'm going to bend those leads. All right. And our jumper, a 5-inch yellow jumper. And that is going to be on the back of the board as well. From eyelet 12 through hole 23.
All right. And while you're doing that, we've got a question here. Thomas Koch asks, Is it normal that multimeters can read capacitances correctly only to around 3 nanofarad?
Testing capacitors outside of a circuit can be a tricky operation. You don't really know how they're going to behave once they're installed and under load or under pressure. So testing them can offer some issues. But if your meter reads capacitance, it's generally good to get you a ballpark. It's not generally going to be very useful once it's installed, and it's not really going to tell you whether that thing's going to pop the first time it goes over its stated rating either.
And what can happen besides it popping or blowing?
If it doesn't work,
Yeah.
It won't perform its filtering or whatever other function it's supposed to be doing. It may just short open or short closed, so it could just stop your signal too. So we've got our eyelet. We've got step 40 now, and this is going to look a little different. This is going to be installing a 25 UF cap, which is this one, and a 470 ohm resistor. The 470 ohm resistor is the tan one in these kits. And we're going to wire these in parallel, which I'll show you. Is that good, Rachel?
Mm-hmm.
So I like to straighten these leads out. These leads all come bent just so they fit in your bin properly. And I find this one sits on there just perfectly. And what you want to do with that 90-degree bend is twist that wire around the lead from the capacitor. And I find one full twist is good. Then I'm going to load that into my helping hands. These are just the standard helping hands you find at a hardware store or online. StewMac is going to start carrying these soon also. Not quite yet. And you can see I tin my tip before I make all these connections just to make sure my soldering iron is passing the heat properly. There we go.
And Tommy, I know you've mentioned it in previous episodes, but what temperature do you recommend setting your iron to?
I prefer 370 Celsius or 700 Fahrenheit. And then that's where I start. And then I just tweak it from there. Sometimes just depending on, the house and humidity and all that, I may need to go up or down. If I find I'm burning my circuit board, I'll actually go up so the tip is hotter and makes a quicker full connection. So again, I've got my cap soldered here, and I'm going to wrap this positive side down. You can see there's a plus. If you can see that, Rachel. You want me to put it down? Okay. So there's a plus on the side. There's also a ring here, an indentation on the positive end. This is an electrolytic cap. It's polarized. It's very important that you install this in the right orientation. So we're going to get that wrapped onto eyelet 6. And again, I want to get it pretty much centered in my circuit board, and then wrap it into eyelet 20.
Tommy, can you point at that positive sign one more time with a little
Absolutely.
tool just so we can do that one more time?
That's our positive side. And on these, the Sprague atoms, it's in green print. It also lists the value. But that positive sign is very, very important.
So positive going to eyelet 20.
Exactly.
Negative coming from eyelet 6.
You got it.
And I had a quick question about this capacitor. We earlier installed 2 of the 0.022 microfarad. This one's 25 microfarad. Why is it so much higher value capacitance?
So this is serving a different purpose also. This is a bypass cap. So essentially it boosts the gain of your power tube by allowing more electrons to flow through, bypassing. This resistor is going to slow some of those. So the value of this will change some of the frequency response of your amp. Some people will experiment with different values, but 25U is a really common value to add as a bypass cap. Some popular mods add a bypass cap here as well. Essentially, this resistor and this resistor serve the same purpose for your preamp tube and power tube. So I'm going to add a 2.5-inch jumper, yellow, at eyelet 20. And again, we'll tack solder that just for our purposes here on YouTube.
And while you're getting that in place, Tommy, Thomas Koch had a follow-up, a little bit of clarification. They had asked, is it normal that multimeters can read capacitances correctly only to around 3 nanofarad? He followed up saying, I meant capacitances smaller than 3 nanofarad are not displayed correctly, like treble caps.
Right. Yeah. So I haven't seen a reliable multimeter test anything in the nanofarads range myself, or at least I didn't trust it. That, you know, if you shell out for a really expensive one, that may be different. I hope that answers your question. Essentially, no, I don't think so. So
That's
on to step 41.
Yeah. On to page 19.
Yeah. So we're going to create a ground bus. All these caps, all these next caps are together on their negative side to ground. So we're going to create a connection that couples all those grounds together. And what I like to do is cut this just a tad longer. This is the only time I'm going to tell you to cut green wire longer in this kit. But this one does need to be just a tad longer just for ease of installation. So we're going to cut a 1 3/4 inch piece, and I'm actually going to go a tad beyond to 2 inches. And if anybody runs out by a 1/4 inch of green wire, you can email me and yell at me, and I'll send you more green wire.
But that shouldn't happen.
It shouldn't. So we're going to cut off all but 5/8 of the insulation. I'm going to use wire strippers for this. And 5/8 here. Shouldn't need to worry too much about damaging this inner core since we're not dealing with shielded wire or stranded wire. So that's what you want to have at the end. You get that, Rachel?
We'll see it a little bit more. It's right there in your hand. Good.
Sure.
Awesome.
Cool. So we're going to feed that up through eyelet 6 from the back of the board. And I'm not seeing it poke through there. And this is a tough one because there's already 3 leads in that hole. But you should be able to smush it through. There we go. I'm going to bend that down using a soldering aid. Again, the green wire is a little bit tougher to bend just with your fingers. Now, I'm going to bend that up and through that hole and just push it flat on the bottom of the board. So now we have 6 and 5 connected. I'm going to bend that wire over, bend the end, and then get it into hole 3. Again, I like to bend that out of the way because we are going to have some leads that go through eyelet 4, which is just a hole. So now we're going to make sure that's in there. And I'm just going to bend that wire over on the back of the board. Sorry if I blocked your shot there, Susan. All right. So that's the first part of our ground bus. The next part is cutting a 3/4 inch piece of wire, which is the right length for sure, and adding that from eyelet 3 to eyelet 2. You can pull the insulation off or not. I'm going to, because that's what the instructions say to do.
So Tommy, what's the significance then of leaving the insulation on the underside of the board between eyelets 5 and 6?
It's vintage correct. Most of the vintage ones had that. It's not super important either way, since there's an insulator board, but it can help prevent shorts in case something wacky happens between your main circuit board and insulator board. There's a lot of stuff going on back there behind. So just that little bit of added protection under the board is not a bad idea, which I can show you. We left the insulation on there. All the other connections that are bare are going to get clipped after we solder.
All right.
So moving right along, we've got our ground bus created.
Yeah, moving on to step 42.
All right.
We're going to add our first filter cap, right?
Sounds right. You just get this a little snugged in here.
Yeah, while you're doing that, I'll just quickly address a question here. Stanley Rocks said, I've had pretty good experience soldering and have an okay knowledge of electronics in general, but never quite this extensive. Would this be a good kit for a first-time builder? Yes, that is really the reason we've selected this kit. We do have other kits, but this one we've selected because it is just a nice, simple circuit and a great introduction to amp building. But if you are interested, if you catch that bug after you build this amp or want to start with something a little more complex, we have 5 different Icon kits, including this 57 mini Tweed 5-watt amp kit. We've got a 59 Tweed 15-watt amp kit, which is actually back there in the background.
It's just a big brother, this one.
Yeah. We've got a 62 Britplex 45-watt, 65 P reverb 15-watt, and a 66 D reverb 22-watt.
Yep, they're all classic, well-known circuits. They're all fun to build. This one's just got the least components, so it's good to get you started. This one can actually be a little tricky because you're working in such a small chassis. So the next components we've got are our 8U filter caps. Again, these pointing to negative, and there is another band here, an indentation on one end, the positive end, just like on our bypass cap.
Hey, Tommy, we had a quick little hiccup there in the stream. I want to make sure everyone gets this really important information.
Gotcha. Okay.
Can you just review that one more time?
Yeah, so these are our electrolytic filter caps. There are 2 that are 8UF, and they are polarized. You really need to install these in the right orientation. Otherwise, they can fail or explode in a pretty magnificent fashion sometimes. So you really need to pay attention to the arrows with the little negative sign pointing to the negative side, as well as the indentation on the positive side. There are 2 of these in this kit, and they go from eyelet 5 to 18. And again, I'm going to kind of center them, figure out where that is. Get through my eyelet. And again here. So these filter caps are responsible for smoothing out the pulsing DC voltage that comes from your rectifier tube. The rectifier is what turns your AC wall voltage into DC, direct current, that the rest of your amplifier is going to use for power. So what these guys do is they smooth out what we call the ripple from your wall voltage that's been increased by your transformer and converted into DC by your rectifier tube. Super important that these are installed properly and that the solder joints are good. If these fail for some reason, it can cascade through the rest of your circuit, knock out tubes, other components, what have you.
Tommy, you mentioned they're going to take care of ripple. Can you elaborate on that a little more?
Sure. So while I'm doing that, I'm going to install another 22K resistor, red, orange, between eyelets 17 and 18. Sorry, I kind of jumped around and didn't do this exactly in the order of the instructions, but I just find this to be a little easier. Did you get that shot, Rachel?
I sure did.
Far out.
Oh, yeah.
So your rectifier tube turns your AC voltage into a pulsing DC current. Your rectifier tube is only going to pass the positive side of each AC wave. So an AC wave goes positive and negative, and DC wave remains positive. Your tube is only going to let the positive side through, so it ends up pulsing every time it hits a positive. So what these filter caps do is fill up every time they're fed positive charge, and then when the positive drops, when the pulse drops, the cap discharges, smoothing out that what would be a pulse into a nice flat supply and takes all the hum out. If you have an amp with a lot of hum, your filter caps are a good first place to check. So we're going to add another lead here. We've got a 2-inch yellow jumper. And we also need to add a 10K resistor. The 10K resistor is a voltage dropping resistor. Is a bigger one, rated for 2 watts, and that's metal oxide. Same deal though, the colors all relate to what the actual resistance is. So pull those little tabs off the end and pop that in between. Now this, you can see physically is kind of big. So what I like to do is bend those leads directly under and get a better span between those eyelets.
Can you hold that up really quick so we can see
Sure.
that bend there? Got it.
Another thing you can do is tip it upright. We do that a lot in pedal kits when it's cramped to kind of decrease the actual physical space between where these two connections go into the board. And I'm actually going to install it like this because it's just a little bit easier to access eyelet 16 if it's up off the board like that. And eyelet 16 is going to get a few more connections, so we really want to make sure that we can get to it. And now we are going to add that jumper, 2-inch jumper to eyelet 17.
Yeah, and for everyone following along at home, this is step 45 of the instructions. Like Tommy said, he kind of jumped a little bit.
Yeah, sorry about that.
We went back to 43 after putting in the second cap. That's step 44. So now we're on 45.
Yeah, I'm just going to tack solder 17 for peace of mind. There we go. Just so that jumper doesn't fly off of there.
Yeah.
Jump
And
off. Oh,
that's the end of step 45.
right.
Moving on to page 20, step
Right.
46.
So we've got our last filter cap and a couple more jumpers. This one is rated at 16U. It's very important that this one is in the right location because it's going to be under the most load. It's going to be the first stage of your high B+ voltage, that DC voltage that comes from your rectifier tube. And again, inspect as you go. You really need to make sure this one is in the proper polarity as well. This one's going to get hit the hardest, and it will explode in a blaze of glory if it's installed in the wrong orientation. I always wanted to say blaze of glory live on YouTube. All right, I've got that wrapped in there in the right orientation. Again, I just want to make sure all my negatives are pointing towards my ground bus. All these indentations are down on my positive side, which they are. We're good to go. So now we're going to install 2 jumpers. We're going to cut a 3-inch yellow jumper. We're going to add that to eyelet 16 from the back of the board. And this is just another reason to have this guy with a little space above eyelet 16. Got it bent there. Then I'm going to run it up through hole 15. Tension should hold that guy in place. There we are. Now we're going to add 3 long jumpers. We're going to cut an 8.5-inch jumper, which will require some basic math. Apologies for that. 6 plus 2.5. Last time I checked. What we're going to do is mark this one. Sorry about that. This is going to go through the back of the board, and it's going to come out of a hole with another lead. It's very important that we hook up the right wire in the right place, obviously. So we're going to just black the end on both ends. The one end isn't as important, the end that connects to the volume pot, but the end that comes out of the bottom of our board really needs to be easily identified. Otherwise, you're going to be hunting it down with a multimeter or something. So what I like to do is feed this down through 23 and pull it through eyelet 4. And I like to get about the same amount on either end, which I've got. Then I'm going to flip my board over and make that wire look a little bit better.
You know, I was going to ask you about this, Tommy. Are there any wires that you need to make sure you're going under or over, or is it really not an issue what they cross?
Not at this stage. Once we get to the sockets in next episode, we are going to talk about lead dressing. But at this part of the circuit, none of this is too important yet. If you can, and you're crossing a wire, it's generally best practice to go in a 90-degree angle. But again, to this point, none of this is going to make a huge difference. Where it does make a difference, we're going to be absolutely sure to talk about it and walk you through it.
Mm-hmm. We've got an interesting question here. Anthony Orzino says, haven't seen much or any need for heat sinking these components. Is that something we're going to be doing in a later episode? Is there any heat sinking?
Not in this kit. None of these are as delicate as something like a germanium transistor or something. All these parts are new. They're all well made, and I have yet to melt any of them just with soldering. Sometimes you'll end up scorching the outside of one of these with a stray soldering iron, but for the most part, heat sinking is not important in this kit.
And for anyone who might be unfamiliar, can you, I guess, explain exactly what heat sinking is?
Sure. So while I'm doing that, I'm going to do our next part here because this is a big one. I'm going to cut 10-inch jumpers, 2 of them. So again, sorry, math, 6 plus 4. Being 10 in Ohio. I'm just going to match them. There we go. So heat sinking is protect the component from excess heat using generally a little copper clip. It can be an alligator clip or a flat clip. We sell them in packs of 10. They're good to have around if you're doing repairs on old, delicate circuits. But for a new circuit like this, it's really not entirely necessary. So what we'll do is get these 2 10-inch jumpers. I'm going to leave about 2 inches, 1.5 inches maybe, on either end. And the rest, I'm going to twist. You want to twist this nice and tight. This is for hum cancellation. This connection is going to be carrying your heater voltage which is a low voltage, high current, relatively high, couple amps, supply to your heaters on your power tube. The heat is what allows the tube to do its amplification. So it's really important that we twist these properly. I've never seen someone over twist these. So if you happen to snap one, take a picture and send it to me. But twisting these too loosely can allow the AC to cause hum in your circuit. This is hum cancellation that's actually kind of similar to a humbucking pickup. The phase of the AC is going to cancel itself if you wrap it in a coil as opposed to running them right next to each other. There's a lot of really nerdy scientific stuff, but for our purposes, wrap it nice and tight and you'll be good to go.
About how much are you leaving on each end here?
I'm leaving about 1.5 inches. I believe the instructions have a little recommendation, maybe not. I leave about 1.5 inches. Again, you can untwist it. It's going to be free on either end once we get to installation. My little jumper here fell out. So what I'm going to do is feed that green coil up through 1. And feed my other end up through 15. 15 is going to be tight. Don't worry if that jumper falls, that yellow jumper falls out. We can put it right back once we have our green in place. All right, so once you get it started, it should start going on its own.
While you're doing that, Tommy, we're getting some good questions here.
Cool.
Sassy Cat asks, how do the quality of the components made today differ from the ones made 60 to 70 years ago?
Technology's come a long way. The construction methods are a lot more consistent these days, and they just know more about what causes things to fail, just like with anything else, cars, computers, you name it.
All right. And then speaking to wrapping these green leads or twisting these green leads to go to the heater, Daniel Seternino asks, then why not have DC heater supply?
It's not how tubes work. They'd have to redesign how tubes are made. It's an interesting question, though. Why not? So there we are. That is our circuit board. That is the end of step 47, aside from inspecting. Again, we talked about the 3 things we were going to do today: wrap our leads, inspect our work, and solder them. We've been going kind of at a slow pace, so we know that everything is in the right location. I'm going to give it a once over to make sure it looks nice, which I think it does.
I think I may have spotted one thing, Tommy.
Oh, yeah?
Eyelet 2 should have a 3-inch green jumper wrapped onto it.
Good eye, Pete. I skipped that one.
Step 46, just at the very end of step 46.
So again, great thing that you can catch that now instead of when you're going to make that connection after you've already soldered it. So good job, Pete.
I'm pretty sure I interrupted you with a question.
Bonus points for Pete anyway.
Wanted to make sure that I didn't screw that up.
So you can see I got my green jumper in there. I lost my ground bus. We'll put that back. Now the next step, everybody, is soldering. So if you didn't have your iron on, get it on now. Again, I like to go 370. Couple really important things for soldering that we're going to talk about real quick before we solder the components, which is step 48. Have a nice clean tip. It should be kind of shiny. Shouldn't be dull or corroded looking.
See that shiny tip.
There we go.
Nice.
And then what we're going to do is tin it every so often. And that little bit of solder on the end there is going to help flow the heat through to the eyelet and the components and help you avoid leaving your iron on there too long and overheating everything. For all these joints, we want to be pretty liberal with our solder. Underdoing it, you know, you could vibrate something free. Overdoing it, you're more likely to get a cold joint. But essentially, you just want to make sure all those little eyelet cups are nice and full and nice and shiny. And you can see when it's fully flowed, the solder kind of wicks out into that cup and makes a nice solid joint all the way around the eyelet with connections, no gaps in there, connections between all the components and wires.
Now, Tommy, is it important at all for this build, I guess, sequence you're soldering these eyelets?
Not at all. I'm going to go left to right, and then I'm going to go right to left on the bottom, just working in order. I'll probably hit these middle ones when I get to the end of this top row. Doesn't matter one bit whether you do them in sequential order or not. We're just going to move right down the line for our purposes. And you can see that's a nice, solid, shiny joint. No gaps in there. That's a good one.
And that number 6 looks really full.
Yep, a lot of stuff in there. Tin this tip a little more.
All right. Charlie Ebarb asked, does StewMac sell these components, circuit boards, capacitors, etc.? I've only ever seen the tools necessary.
We sell all this stuff in a kit. We do sell nearly all these parts as far as the components on their own. We sell the wire. We don't sell the eyelet boards. Those you can source elsewhere, places like Seriatone, Mojotone, but they're pretty specialized as far as all these eyelets being in exactly those places. But yeah, so we don't sell the boards, but we sell everything else essentially. We don't sell the chassis. We don't sell the cabinets, but there are a lot of other places you can buy that type of stuff. All right. Moving right along.
All right. We've got an interesting question here. Oh no, where'd it go? Here we go, from Howard Holland.
Hi, Howard.
Hi guys, in your last video, you showed the fuse in the neutral line. That fuse should be placed into hot line in case you have a short in the primary winding, according to NEC. Can you address that? I'm not exactly sure what he's referring to.
He's not wrong. So National Electric Code is NEC, and their standard is that the fuse should be on the hot, not the neutral, in case you have a short in your primary winding of your power transformer, so you don't end up with essentially wall voltage on your chassis. For this amp kit, you can absolutely do that. It's just how our instructions are, and it's really not the end of the world in these kits. Although if you want maximum safety, absolutely flip those white and black wires in step 1, I think.
I can find
episode
1, yeah.
2, maybe, when we wired the power transformer.
Yeah, that is episode 2.
Yeah. So I've got my top row all done. I'm going to inspect it one last time. You don't really need magnifiers. These are big enough joints that you can generally see if you missed one. And now I'm going through, I'm going to hit these middle 3 first before I get to the rest of my bottom row. And for 14, it's kind of crammed in between those orange drop caps. Just going to smoosh that guy over so I can get a little bit better access and maybe a better camera shot for you folks.
You tilt the board a little bit more towards the meeting, or the whole
We'll get that in there.
Okay, it would be step 21 in the previous episode.
Sure. Yeah. So step 21 in episode 2. I don't have the timestamp. Sorry, guys. If you want to switch those, it would be safer in case of a major catastrophe inside of your primary winding of your power transformer. I have yet to see a faulty power transformer in one of these amp kits, but it's certainly if you're concerned about that. So now I'm going to just continue on my bottom row here. Eyelet 14. All right. Nice shiny joints. Again, I leave this on there on those eyelets for just a second longer after I remove the solder to just cook all the flux off that I can. Flux is just a component part of solder. Here we go.
All right, while you're soldering that eyelet, Benjamin Marn asks, does the StewMac eyelet setter work on Mojotone made eyelets? Is it made for the pickup eyelets that StewMac sells? I'm building my board from scratch.
Yeah, it's made for those pickup eyelets, the small brass ones. We don't have one that's good for these big eyelets. So we're going to solder eyelet 17. We're not going to solder eyelet 16 because we still need to add a lead from our power output transformer, not power transformer, later on. So we're going to leave eyelet 16 unsoldered, but we are going to do eyelet 17. And that will be our last step for today.
All right. And while you're doing that, we got a question. It's sort of being answered in the chat already, but Tony Simonen says, does the setup work with 240-watt wall power?
It does. If you go back to the other episodes, we talk all about the international taps on the power transformer.
Yeah, which you can find on in step 10 of the instructions. It lists the different leads to set up your amp for the different wall voltages.
Yep, different primary taps. So we are done with step 48. What I'm going to do as our last little step or process is flip this board over and cut all my excess leads. I do have one excess lead on the front of the board as well at 14 here. I don't know if you'll be able to see this good, Rachel, or not. How's that? Nope.
Yeah, we knew it was there.
Yeah. So I'm going to go ahead and flip my board.
So Tommy, I notice you're trimming these leads with the flush cutter, or excuse me, the diagonal cutter, rather than the just snips you were using earlier. Is there any reason for that?
You can get really just a bit more precise. You don't need to go crazy getting all the way down onto these eyelets. Because again, we have that insulator board, but you want to make sure they don't short to each other, obviously. So just within reason, cut these back to the eyelets. You don't need to go crazy worrying about all these little leads, but I probably will just because I like for it to look as nice as possible. Those will go flying. Make sure you're wearing eye protection or put your thumb over it like I'm doing, or both. Sorry if I'm blocking your shots there, Rachel.
You get that. We're getting most of it.
You get the idea.
Get the idea, yeah.
All right.
No trade secrets in this part, folks.
Just snipping.
Just snipping.
So if you're following along in the instructions, of course, we're finishing up step 48, page 21. That's going to be our last step for today, right?
Yeah. So this is another good chance to inspect your work. Looking at the back of the board, you can really eyeball those solder joints and see if any of them were missed or if any of them look really cloudy. Everything's looking pretty all right to my eyes right now. And again, this bottom corner isn't going to be done. That's good. We need to add one of our output transformer leads there again. So we're going to do that once the board is installed in the chassis.
Right, and that is mentioned in the instructions as
Yep.
well.
Absolutely.
Leave eyelet 16 unsoldered for now. And we'll be doing that next time, right?
Exactly, yeah.
Yeah, so next week or next episode, we're going to be installing the populated eyelet board that we've just finished and to our chassis that we prepared in episode 2. What else are we going to be doing? Is there...
So next
lot of
episode, we're
hookup?
going to install this board into the chassis. You said that, right?
Yeah.
And then we're going to add a few connections from some of the components that are in the chassis right now, like our rectifier tube. We're going to connect all these leads to where they need to go. And we're going to basically wire up all our sockets and get essentially everything wired up. And then I believe in the last episode, we're going to hook up power and start testing.
All right.
But we're done for today. Don't forget to remove your tape. The vintage boards didn't come with StewMac orange tape on them. So if you're going for vintage appropriateness, definitely don't leave the best tape on there that you can find.
And that tape's low tack enough that it shouldn't damage your board or anything like
Totally.
that.
Yep. So there we are. That is the
All right.
end of today's episode. That's a pretty good looking circuit board.
Fantastic. Well, I want to thank everyone for joining us for episode 3 of our live amp build. Please join us again next Monday, December 14th, 3 p.m. Eastern, where we'll be live again with episode 4. Again, thank you so much, folks, for joining us. If you aren't able to catch all of the episode, we have all of these episodes up saved on our YouTube channel, so you can always go back and review them. Plenty of great information. If this is your first video, go back and watch from the beginning. I just want to give a big thank you to you, and especially to Tommy Stumpp for leading us through this.
Thanks, Pete. Thanks, Rachel. Thanks, Susan.
Yeah.
Thanks, everybody, for watching. Please come back for next episode. We'll keep building our amps together.
It's really coming together. Have a great night, guys.